Okay, we're going to be looking at highest common factor problems in this video. You should have watched the videos on finding the highest common factor of two or more numbers before you watch this. If you haven't, or if you're not sure how to find highest common factor, this video is not going to be very helpful because it's more problem solving type questions. So just before we start, we're going to get a few definitions in. So we know a multiple is something that is in a numbers times table. So an example of this is multiples of 4 are 4, 8, 12, and so on. So 4 is included as a multiple of 4 because it's 4 times 1. A factor is a number that fits into another without a remainder. So for example, with the number 10, we can fit 1, 2, 5, and 10. These are all factors of 10. People always forget that 1 is a factor and the number itself is a factor of itself. So just remember that. And then HCF, the highest common factor, is the biggest number that fits into another without a remainder. So usually this is referring to at least two numbers. Sometimes it's 3 or 4 or more numbers. So for example, the highest common factor of 10 and 15 would be 5. Another number that goes into both is 1. But the highest common factor is going to be 5 because 5 goes into both. Another example of this is a highest common factor of 20 and 40. Well, the biggest number that goes into both is 20. So you're allowed to have one of the numbers itself as a factor of both. So this is a quick practice exercise that you can do before you continue with the video. Just to check, make sure you have the skills, pick a few at least to do. Okay, so here are the answers. I'm not going to go through the method. You can watch the other video for that if you need. We'll go straight to a problem solving question. So sometimes, rather than being given numbers like 20 and 34 or 30, 24, you may be given numbers like this, given as a product of primes. So for example, 10, which is 2 times 5, is quite easy to work with. You can easily work out the number as the original number. However, you may get something like 13, 7 times 13 times 3 times 2 to the power 4. Now that's a very big calculation to do. Usually those numbers are in order, and you don't have time to do that. But you're going to see why this is a nice representation of numbers and how we can use that to work out various things. So this is a true or false. We're not going to work out the number y itself. We're just going to be using this fact that we can represent this number as 2 times 5 times 5 times 7, or 2 times 5 squared times 7. So true or false, y is a multiple of 2. Well, this number here is in the 2 times tables. So we know that 2 is a factor. So 2 goes into it, which implies that it is a multiple of 2. Essentially, it's 2 times whatever this gives us. So yes, this is true. The next question, 7 is a multiple of y. True or false? Have a think. Okay, so 7 is a multiple of y. Now what that means is on the y times tables, you're going to end up with 7. Now, if we look at our number here, the number itself is multiplied by 1 to give you the first answer. And you multiply it by 2, and then keep multiplying, and that will give you the multiples of this number. Now, 7 is not a multiple of this number. It's definitely a factor, and it does fit into the number, but it's not going to be a multiple. So this is false. 35 is a factor of y. Now, because we don't know what the original number is, we're going to be using this breakdown here to figure out, can we make 35? We know that 2 is a factor. We know that 5 is a factor. We know that 7 is a factor. But we can also multiply these numbers together to make other factors. For example, 2 times 7, 14. 14 is a factor because that's a number that fits into this. 2 times 5, which is 10. 10 is a factor. Now, is there a way to make 35 from this? So you probably spotted 5 times 7, so that is 35. So yes, 35 is a factor of y, because we can say, for example, we can write this number as 2 times 5 times, now this bit here is just 35. So 35 times 10, that actually tells us the original number, but we can see 35 is a factor, so that's true. And then 350, now we've already worked this out in the previous bit, so 35 times 10 is 350, so yeah, that is our original number. But I want you to notice that we didn't work this out to answer any of these questions. So let's try another example. If you could find the highest common factor of these three numbers, if you don't remember the method, you're going to find the highest common factor of these two numbers, and then whatever that answer is, you're going to put that with 49 and then find the highest common factor of those two. Here are your answers for you to check as you practice. And we're going to be looking now at some worded true or false questions. So pause the video and have a go at all of these, decide whether they're true or false, and then I'm going to go through some answers with you. Okay, so the first one, highest common factor of 6 and 25 is 1. Well, we can see that there's no other numbers that go into this, so yeah, this is going to be true. The highest common factor of the largest factor of 24 and 32 is 4. You may have spotted, either you worked this out or you might already know that 8 is going to be a bigger factor, so that's false. Given that 80 is equal to 2 times 2 times 2 times 2 times 5 and 180 is that, the highest common factor of 80 and 180 is 20. So to find the highest common factor, we're going to look at factors which are common and then combine them together. So 2, we've got another 2, then we can see we have a 5. There's nothing else that matches, so 2 times 2 is 4, 4 times 5 is 20. So that implies that this is true. There's no, these factors do not mix. So the highest common factor of 3a and 6a is 3. Now we know that the highest common factor of 3 and 6 will be 3, but there's also an a which is common to both. So this is false, this should be 3a. Highest common factor of 27, 99 and 18 is 9. Well, let's divide all of these by 9 because they're not too tricky to work with, these numbers, and then see if we can simplify it more. So 27 divided by 9 is 3, 99 divided by 9 is 11, 18 divided by 9 is 2. Now you can't simplify these anymore, there's no other common factors, so this is going to be true. And then the last one, look at the numbers first and then the letters. So 2, 16 and 4, the highest common factor would be 2. And then we've got n, nm and n squared, so highest common factor there would be n, so this is true. Okay, so some more problem solving questions. It says find the highest common factor of 2022 and 4002. One way to do this is to just write these out with the bus stop method. That could get quite long. Luckily, the question has provided us with the prime factor breakdown. And this one is not a very nice number to deal with, but luckily we don't have to. So the highest common factor is going to be the numbers which fit into both original numbers. So 2 is common to both. 3 also fits into both. And you can see there's no other common factors. So 2 times 3, which is 6, is the biggest number that you can divide both 2022 and 4002 by. Okay, so another example here. Work out the highest common factor of the two numbers written as a product of prime factors. Now, again, important to notice, we don't actually need to work out what the original numbers are. Doesn't matter, we don't need to do 53 times 7 times 5 times 3, but we do have the two numbers given to us in prime factor form. So what's common to both? Because you want common factors and we want the highest ones. So 3, 7, and that's it. So 3 times 7, which is 21. That's the highest common factor of both of these numbers. So try the one on the right, then I'm going to go through it. Okay, so we can see 2 doesn't work, 5 is not common, 13, there's at least one pair that goes together, and there's a second pair as well. We got 29 as well. So here we can say 13 times 29. I'm not going to work that out here. Actually, I will use my calculator to work it out. You probably wouldn't get something like that on a non-calculator paper. So 4,901 is the biggest number that goes into A and B.